improper integral. We want to evaluate the improper integrals. And one of the examples is to integrate from 1 to infinity dx all over x squared. And we know that at the point of the improper integral, so what we do is we would write this in terms of a limit from 1 to b dx over x squared, and that will give us limit as b tends to infinity minus 1 over x, and then we put our limits from 1 to b because we have the infinity as part of the integral. So when we find the limit as b tends to infinity of 1 minus 1 over b, this will be equals to 1 minus 0. It will be equals to limit as b tends to infinity e to power x negative b to 1, which is a limit as b tends to infinity e of x e of 1 minus e of minus b. And as we put b tends to infinity, e raised to power minus b will be equals to 0. So the answer will be e raised to power 1, which we can also write as e. Cos x dx, which is basically limit as b tends to infinity 0 to b cos x dx, which is equals to limit as b tends to infinity sin x 0 to b, which is limit as b tends to infinity sine of b minus sine of 0. And what we know is as b tends to infinity, sin b oscillates between negative 1 and 1. Hence, sin b does not approach any number. So that's what we want to keep in mind. And then finally, if we have an improper integral given by integral from 0 to 1 dx all over square root of 1 minus x, where we have a discontinuity as x is equals to 1, it's the limit as b tends to 1, 0 to b dx over square root of 1 minus x. So we know that there is a discontinuity when the value of x is equals to 1, and this gives us limit as b tends to 1 of this equation. And how we do approach this equation? We let u is equals to 1 minus x, and then the x is equals to minus du, and therefore it will be the integral of u raised to power minus half negative du, and this will be minus 2 u raised to power half, and that will mean limit as b tends to 1 minus 2 u is 1 minus x raised to power half, and I'm looking at 0 and 1. So when it is 1, it is 0, and when it is, so this instead of 1 I'll put b, so it will be limit as b tends to 1 minus 2, 1 minus b to power half plus 2, and therefore the solution for that will be equals to 2. So that is how you handle the improper integrals when you have been given, particularly when there are also discontinuities as given point. And I'm sure you've enjoyed this video. Please do subscribe.